Hello everyone, my name is Ali Ibrahim and today I'm gonna show you the demonstration of SETMOKE API which is built on Urdu Semantic Engine. The entire project is totally funded by Technology Development Fund provided by HEC. Now, before delving into the modules of SETMOKE API and the functionality of it, let's first discuss the need of such API. As we all know that with the increase of Urdu speakers globally, enormous number of Urdu articles are being published in various journals and websites. Despite being ranked 18 in the world, Urdu is still considered under-resourced because of lack of quality corpora and text processing APIs. Although there exist several application programming interfaces such as NLTK, GenSim, Spacy, TextBlob, and many more which can process the text written in famous and renowned languages such as English, Chinese, Japanese, but they are still lacking specifically for Urdu language as they don't have any module to process the text written in Urdu language. This is why nobody has developed any significant applications such as email spam detection, product review analysis, sentiment analysis, fraud detection, and many more, just like summarization, classification, and named entity recognition specifically for Urdu language. Now, in order to revolutionize the development industry and academia through the development of such applications, Data Science Lab of KICS has developed an API known as SETMOKE over Urdu Semantic Engine in order to manage and process Urdu text efficiently. The entire project, which is namely as SETMOKE, was funded by HEC as they provided Technology Development Fund. Our SETMOKE API has 6 major modules and it also provides benchmark datasets for various natural language processing tasks. Now I will discuss all the modules one by one to give you a better idea what exactly SETMOKE API has for various researchers and practitioners. Our API has 6 different modules and I'm gonna show you the working of each one at a time. So here we have SETMOKE API interface. It has 6 major modules. For example, summarization, classification, information retrieval, sentiment analysis, and stemming, peer tagging, or named entity recognition can be considered a pre-processing module. So let's start with stemming. This is the main interface of stemming, where I can actually input a file and apply stemming by infix, prefix, or postfix rules. So let me input a sample file here. I'll find the sample file. I can tokenize, and here we have the drop down because we are planning to extend this for various other languages as well. I can extract stop words by using this default list or uploading a new one. And here we have the content without the stop words. I can apply infix rules, apply prefix rules. I can also apply postfix rules as well, so it's perfectly working. Now let me show you the working of peer tagging. I'll input the same file and apply peer tagging. It will take some time. And here we go. We have different tags: proper noun, noun, adjective, adverbs, and many more. Let me quickly show you the working of named entity recognition. This is the main window of named entity recognition where we can actually train our model on a new corpus, but as I have already trained my model over the sample corpus, so let me show you the prediction of it. I'll input a sample file and extract entities. So here we have a couple of entities which are extracted by our trained model. Okay, and we are currently supporting these 7 entities here. Let's move on to sentiment analysis. I'm not gonna train my model as I have already trained the model over sample corpus. So let's straight away make a prediction. I'll input some data I'll select a test file. Here we have a couple of sentences, and now I'm gonna predict the sentiments, and it has predicted, and our sentiment analysis module find three sentiment categories: positive, negative, or neutral, and here we have all the tags. Great. And we can repeat the process for other form of Urdu, which is Roman Urdu. Let's move on to text summarization, which is able to generate the summary using extractive summarization techniques. Let me input a sample file. I'll upload a sample file, and now here we can see the statistics of this particular file. I can tokenize, as I've already shown you. I can apply stemmings. I can remove those stoppers using default list or provide a new stoppered file as well. Now straight away move to summarization. We have implemented so far 5 algorithms, as you can see. Now let me generate the summary of Lex. Let's say 3 number of sentences for the summary, and it will generate the summary. We can also upload the gold file and check the rogue or blue score. Great. Now I'll show you the demonstration of text classification. This is the main API interface of text classification. I'll upload the corpus and then classify by splitting the dataset. Select the sample classification dataset. As you can see, the statistics of the dataset have been shown. Split in 70-30. We have implemented 10 filter based feature selection methods: RDC, NDM, MMR, Poison. So let's select NDM. We have implemented 2 feature representation approaches: TF, IDF, and TF. We can apply both of them as well. Let's go with TF. Classifier, SVM, and knife base, and evaluation measure accuracy. So let's start classification. It will take some time. And here it has produced the accuracy of 0.53 over 10 number of features. This is the entire number of terms which our underlying model has exploited. Okay, now let me show you the demonstration of question classification, which is similar to text classification. Okay, let me show you the demonstration of question classification. Here we have the demo of question classification. I'll straight away, without wasting any time and without training our model again, show you the prediction. Let me input a sample file. This is the sample text. A couple of questions about different categories, and we have divided our dataset in 3 different forms, having 3 different types of categories. So let's predict 3 number of classes. I'll predict that, and it will eventually gonna classify in either easy, medium, or hard. Here we have. So I can utilize another model for a 6 number of classes. Let me select that and predict the classes, and it will eventually predict the classes in terms of description, location, and here we go. Great. So question classification is perfectly working as well. Now the last one, which is the information retrieval. First of all, we have to create a new core in order to index a couple of documents and then a query afterwards. So let's create a new core. I'll give a sample name, test core, English and Urdu. Let's suppose we select English. Index path, anything, and we will create the schema. So schema has been created successfully. Now I will index a couple of documents in this particular test core. select the corpus having all the documents which need to be indexed, and I'll start the indexing. So it will take some time to index all the documents. All the documents have been indexed successfully. Now I will search document. Now I'm not gonna put any queries. Let's search with the static. So it will eventually rank all the documents according to the particular user query. So here it was the demo of SETMOKE API. Now this SETMOKE API has been evaluated over different datasets. For example, classification module has been tested over 3 different datasets like DSL and CLE dataset. These are the statistics of those datasets, and it has produced the F1 score of 93 with term frequency and 94 with TF-IDF. Similarly, it has produced promising results on CLE datasets as well. Summarization has produced the ROG1 score of 34 and Blue of 41 as well. Urdu question classification has produced the accuracy of 93 over the dataset. Sentiment analysis produced the accuracy of 97, and these are the statistics of various datasets. For information retrieval, we used 500 document dataset as well. And for more information, we have also created 2 detailed documentation. One is named as Urdu API, which is more of technical in nature because we have covered all the modules, their methodologies. For more technical documentation regarding the functions, we have prepared SETMOKE API documentation, which is pretty user friendly, and here you're gonna find different functions and their parameters and their output as well. So this is a pretty extensive documentation regarding different modules and what we need to provide to a certain function in order to achieve certain task. So this was the complete demo of SETMOKE API. I hope you people liked it, and you can post your valuable feedback by logging on to the official website of KICS, which is dsl.kics.edu.pk. SETMOKE API can be considered a milestone towards Urdu text processing, as it provides various efficient modules for various researchers and practitioners that can prove pretty crucial to develop diverse applications. In order to illustrate this point, let's consider 2 case studies, namely complaint filtering and criminal case log aggregation and summarization systems. Typically, in complaint filtering, when complainer lodges a complaint against certain issue, that issue needs to be classified as valid or invalid based on certain facts and figures or the intention of the complainer. In this regard, our SETMOKE API pre-processing and classification module play a crucial role to classify filed complaint as valid or invalid. Likewise, criminal case log aggregation and summarization system mitigate the case analysis time by generating the precise summary from the remarks posted by high profile investigators, just in order to ease the lives of higher management. So in this regard, our SETMOKE API summarization module can prove and play an integral role in order to generate pretty coherent and precise summaries for higher management. Till the next video, Allah Hafiz.